Okay, number two, given a singly linked list, rotate the linked list counterclockwise by k nodes. So this will be our example here of a linked list. And if we have k of 4, what we're going to be doing basically is taking the first 4 nodes and then just rotating it so that the 10 would come back down here, and then we'd just be reiterating that until, as we can see, starting at 50, 60, and then we have the remaining 4 nodes coming after that. All right, so we have our linked list, and our k is equal to 4. And so what we're going to do is we'll have a head at the beginning of the linked list, and then we'll have a current node is we'll be using as our pointer, and then we'll have a count that we'll initialize to 1, and then what we want to get current to our 4th node, and so as long as count is less than k, current isn't null, we'll be moving this down and increasing the count. So if we do that, right, and when we have our count equal to k, we'll have our current pointer pointing to 40, and if current equals to null, that means k is more than the linked list, which we just wouldn't return anything. And so then we're gonna label this node as our kth node. And so that will, and then we will be continuing having current go down until we hit null, and then we'll be having a head at 50, starting over, and then current will come down to null, and once current next, we'll have this while loop as long as current next is not equal to null. But once we get to the end, we're going to be coming back down to the head and rotating around, and so that will get us with our head at 50, and then we'll just be rotating it along again back to the head. And then once we get to kth node, we'll have kth node next will be equal to null. Running out of room there. But yeah, and so then that gives us our rotated linked list where we are starting at the node after the kth node and then rotating it around. And then the time complexity is O of n.